Welcome back to Edupedia World. In the last lecture, we saw about different forms of energy and interconversion between them. Today's lecture will be focused on the two types of sources of energy, the renewable source and the non-renewable source. And we will close the chapter of work, energy and power with production of energy from different sources, that is from solar, from wind, from hydro and from nuclear sources of energy. Let us get started with the last lecture on work, energy and power. In our day-to-day life, we require energy to carry out a lot of processes for life to sustain. Nature has given us a lot of forms of energy which we use to carry out our day-to-day activity. These energy sources has certain properties that it can provide energy over a long period of time and in a safe way which is convenient to use and can be transported quite easily. These are some of the characteristics which a source of energy should have. Now if we try to classify the sources of energy, broadly speaking, we can classify it into two categories. One is called a renewable source of energy. Renewable source of energy, and the second is non-renewable source of energy. The renewable source of energy is also called as non-conventional source of energy or non-conventional source, and non-renewable energy is called conventional source of energy. What do we mean by renewable or non-conventional source of energy? What it means is that the source which is providing the energy is a constant source of energy. That is, the source is always present and is continuously replenished. It will not be exhausted out. It is a continuous source of energy. So we can say that this is continuous source of energy. Non-renewable, on the other hand, refers to the sources of energy which can run out. That is, they have been formed in the nature over a course of period. It has taken a lot of time for those sources to come into existence. So once we start using it, it does not continuously get replenished. It takes a lot of time for the source to generate the amount of energy that we are using again. Therefore, it's not a continuous source of energy. Hence, it is called non-renewable source of energy. So this is not a continuous source. Not continuous. Now let us see the renewables or the non-conventional sources of energy in details. We will see several examples of renewable sources of energy. One of the most important example which we encounter in our day-to-day life always is the solar energy, that is the energy of the sun. I'm noting this as 1 and this as 2, and this section is for 1. So under 1, the first is solar energy. The sun is a continuous source of energy for Earth. It continuously burns its internal fuel, undergoes nuclear fusion reaction within the sun, and radiates out energy throughout the space, and we humans on the surface of the earth receive a part of it. but the source is a continuous source, and we are trying different ways to capture that energy. We are using solar cells, we are using solar panels, and we are doing a lot of research to improve the efficiency to make use of that continuous energy source, the sun. The limitation of solar energy is that the energy density, that is the amount of energy we receive on the surface of Earth per unit area, is quite low. So the energy is basically dispersed out a lot. Therefore, it is not focused at a place that we can just go over, let's say, 10 square meter and get a lot of energy out of it. But we need to spread the solar panels over a larger area to get more useful energy. Now, after sun, a second source of energy in our day-to-day life which we always encounter is wind. Wind energy is also a renewable source of energy because it is not something which is found by accumulation over a period of time. Rather, it is a continuous source of energy when it occurs whenever there is a pressure difference between two regions, which leads to the flowing of air from one place to another, and that leads to wind. And this movement can be extracted into useful forms of energy. It can be used to rotate turbines and by the use of windmills and help produce electricity. So wind energy is another source of renewable source of energy. The flowing water is flowing water or hydro energy. Let me write flowing water or hydro energy. Hydro energy. What is this? Rivers continuously flow. Why? Because water has a natural tendency to move from a higher region to a lower region due to gravity. Now, this flow of water can be utilized to run turbines, and that running turbines further produces electrical energy. Therefore, water is a source of continuous energy, the flowing water. Rivers are always running. And what makes the water go from a lower level to a higher level? That is basically the evaporation of water by the solar energy and then precipitation through rainfall that makes the water complete the cycle and again flow from a higher region to lower region. Therefore, it is a continuous source of energy because solar energy is a continuous source of energy. Now we have biomass as another source of energy. What is biomass? Biomass are wastes and dead parts of living beings, and these waste and dead parts of living beings can be used to produce energy because those waste or dead parts have chemical energy stored in them. And why is it called a continuous source? Because these wastes are continuously produced. It's not like it's not an accumulation over a period, it's a continuous source. So biomass is also a continuous source of energy, and the chemical energy stored in it is basically called as the bioenergy. Then we have tidal energy. Tidal energy. What is tidal energy? Tidal energy basically refers to the energy of tides. What are tides? Tide is an effect of the effective gravitational pull of the sun and the moon, which results in the height of water level in the oceans to rise during high tide and to fall during low tide. And this continuous rising and falling of water level can be utilized to extract energy. And this is a continuous process which happens after every periodic period of time. Therefore, it is a renewable source of energy. The only problem with this is that the tides does not generate a lot of energy. So we cannot completely rely on this as a source of energy. Rather, it can contribute as part of our energy requirement. Then we have oceans as source of energy. Ocean can be utilized in two ways. The first way is called ocean thermal energy. Ocean thermal energy. What is that? The water at the upper levels of the ocean is heated by the sun, whereas water at a deeper level is not that hot, it's rather cold. And the temperature difference between the top and the inside of the ocean is somewhere around 20 degrees Celsius. And this gradient of temperature can be utilized to produce energy, and this energy, the production of energy using this gradient, is a result of ocean thermal energy. This is called as the ocean thermal energy. So this is one of the ways that ocean can be used to produce energy. A second way is the waves energy. Oceans produce continuous waves. There are a lot of waves being produced by the ocean, and these waves are source of energy, as in that can be used to run turbines and produce energy. Therefore, wave energy can also be utilized and is a renewable source of energy. Now if we go further, we have nuclear sources of energy. What is nuclear source of energy? Nuclear source of energy refers to the source of energy in which nuclear fuel is used to produce energy. Say for example, uranium. Uranium is a radioactive material which undergoes nuclear fission reaction, and it produces energy, a lot of energy in fact. It basically uses the Einstein mass energy equivalence, that is E is equal to mc square, where m refers to amount of mass lost, and that loss of mass is converted into energy, and c being the speed of light, the amount of energy produced per small unit of mass loss is huge. So a very small amount of fuel can produce a large, very large amount of energy. Therefore, renewable energy is also actually considered under, rather nuclear energy is also considered under a renewable source of energy. Now let us see some non-renewable sources of energy. As we discussed during the start of our lecture today, that non-renewable source of energy are the sources of energy that has accumulated in nature over a long period of time and cannot be replenished when exhausted instantaneously. They need a lot of time to be replenished in the nature. So they are called non-renewable energy sources. Now let us see some of the types of non-renewable sources of energy. One of the most common type, or the most common example, is coal. You might have encountered coal in your home also. Previously it was used to produce energy or produce heat, which in turn was used to cook food at your home. Now it has changed with the availability of LPG. So what is coal? Coal is a non-renewable source of energy made of many complex compounds, in which basically the carbon is the main energy component. So coal, when burns in air, it forms carbon monoxide, carbon dioxide, and it produces a lot of heat. It also contains nitrogen, sulfur, and such other stuff. Then the second non-renewable source, which is extremely popular, is petroleum. Petroleum refers to a dark viscous liquid which is also known as crude oil. It's also called crude oil, and it is a complex mixture of many hydrocarbons with impurities of salt, earth particles, water, and other compounds including carbon, oxygen, nitrogen, sulfur. Petroleum is so very popular because it produces the energy sources for our vehicles, the diesel, the petrol, such things. And it is kind of lifeline of today's modern world. So petroleum is a very, very important non-renewable source of energy. Now the process which is used to separate the useful components of crude oil using the refining processes is called the refining, which is done through fractional distillation. Basically, petroleum has different components which has different boiling points. So fractional distillation is utilized to separate the different components, and now these different components have slightly varying properties, and the different components are used as per their properties wherever they are suitable. So fractional distillation is the method to separate out the different components of crude oil. Now the third very popular non-renewable source of energy is natural gas. Natural gas. Natural gas is a non-renewable source of energy which is found deep within the Earth's crust, either alone or it might be found above the petroleum reservoirs. So it is in the form of gas, whereas petroleum was in the liquid form, so it was a oil form. And natural gas is a gaseous state which either occur independently or occurs above the petroleum, above the place where petroleum is available. Now different places where we find that there is petroleum gas, natural gas available, wells are dug to extract that natural gas. These three are the main non-renewable sources of energy which we will discuss in today's lecture. As we see, all these three, coal, petroleum and natural gas, takes a lot of time. It takes several million years to be replenished. Therefore, the name goes the non-renewable sources of energy. We have a clear outline about the difference between renewable and non-renewable sources of energy, and we have seen different examples of what comes under each category. Now let us close our lecture today and the whole chapter of work, power and energy by trying to understand a little about how energy is utilized, or how energy is used to produce electricity in the case of solar, hydro, wind. In the case of solar energy, solar panels are used to extract the energy of the sun. Solar panels. What do they do? What happens basically is the solar panel is made out of semiconductor materials which has been finely doped with impurities, and when the solar energy falls on such panels, a potential difference is created between two surfaces of the panel, and that potential difference can be utilized to produce electricity. We are not going to discuss in details about how exactly the process is being carried out. That is beyond the scope of the syllabus. what we need to know is that solar panels is the equipment that is being used to extract the solar energy into useful electrical energy. Now, secondly, we have wind energy. Both the wind energy and the hydro energy, that is the energy due to flowing water, has similar concepts to extract energy. We extract energy through both using similar concept. What we do is basically we have turbines, water turbines. Turbines are something like this. I'm just drawing a pictorial representation for the example of wind. These are basically panels like something like this, and when wind flows, suppose the wind flows from this direction, then it will start revolving the panel, and since there are multiple, it continuously revolves from the direction of the wind. This will move in this direction, and this rotation is passed on to a generator, and that rotation helps produce the electricity. Similarly, in case of hydro energy, if there is a flowing water, suppose the water is flowing, and if we set up a turbine here, then this flowing water will revolve this turbine, and that revolution can then be utilized to produce electrical energy. This is a broad picture of how wind and hydro energy is used to produce electrical energy. Now, the production of electricity from nuclear energy. As we just discussed, nuclear energy is basically energy from the nucleus, which is because of conversion, loss of mass, and conversion of that into equivalent energy by E is equal to mc square. What happens is that due to the loss of mass, energy, a lot of heat is produced. That heat is in turn utilized to heat water to steam. Water is converted to steam, and this steam will in turn then rotate turbine. Again, it will rotate a turbine. Suppose the reaction is taking place here. Uranium is undergoing the nuclear reaction and it is producing a lot of heat. There is, let's say, some water here, and that heat is converting the water into steam, and this steam is then passed on from the turbine, let's say like something like this, and then this steam is continuously hitting the blades of the turbine and helping it revolve, and as a result electricity is being produced due to the revolution of the turbine. So we see that by using engineering in a proper way, we can use it to convert different sources of energy to electrical energy. And that is what engineering is all about. It's about trying to find ways in which we can produce something which we need from something which we have available. Okay, so with this we have a picture about how electricity, that is the main source, one of the major technological advances of our generation, is being produced from completely different sources of energy. With this, I will close today's lecture, and I hope that with all the lectures, all the previous lectures, we have a much clearer understanding of the whole concept of work, power, and energy. Next up, we will study about machines. So till our next lecture, have a great day. Goodbye.